Alright guys, welcome back. This is part 2 of 3 where we're going through the answers to the homework that is due Thursday, February 24th. I'm going to start where I left off in the section that says solvent versus solute. We've got a paragraph here and it reads, in oxyacetylene welding, the flame produced is over 3,600 Kelvin, which is the hottest burning common fuel gas available. This outrageously intense gases mixture contains 20% acetylene and 80% oxygen. What is the solvent and the solute of oxyacetylene? To answer this question, we need to look here at the percentage breakdown of oxyacetylene gas. You also need to know that the solvent in any gaseous mixture, and I'm going to write this down for you, is whatever is the most abundant part of the mix. So I'll say that again. The solvent in a gaseous or a solid solution is the most abundant part of that mixture. What does most abundant mean? Well, we could look this up if we wanted. Look up the definition. It says plentiful, adjective. Plentiful means whatever there is the most of. In this case, we know that 80% is greater than 20%. So we would say 80%, the oxygen is the solvent because it is the most abundant. Looking down here, we've got another more simple example. Sugar dissolved in water. Well, the solvent is whatever does the dissolving. In this case, it is the universal solvent, water. Yay! And the solute is whatever gets dissolved, sugar in this case. You have seen that a million times in class. The second part asks you to make your own, and you know what? I'm not going to do that for you. Let's look down here. It says water's properties. What attractive intermolecular forces of water cause the meniscus shown in the graduated cylinder? You need to remember that the meniscus is that thing, the curve we always measure from the bottom of the meniscus. When we look at the choices, combustion, magnetism, surface tension, and high pressure, surface tension is the only one that we should recognize. Surface tension is caused by hydrogen bonding between the water molecules on the surface, and that same force interacts with the sides of the graduated cylinder and makes the water almost try to climb up the walls, causing that distinctive sort of C shape. Part 2 says, draw a picture of 3 water molecules focusing on how they would arrange themselves. Hint, water has a bent shape and partial charges. You know what, let's just go to Google. Instead of me trying to draw, let's actually just go find a picture. So, water molecules. When we look at something like, I can pull this up, a picture of water molecules. Here's 5 water molecules. Notice the hydrogen bonds that exist between all 5 water molecules. Notice also that the red balls align themselves with the white balls, or the hydrogens are matching up with the oxygens. Notice that there is a partial positive charge on the hydrogen and a partial negative charge on the oxygen. So you could just draw something like this. Number 3. So we could say, use Google Images. Number 3. Now add a single potassium ion and a single chloride ion to your picture above. Make sure they're in a correct spot. There are multiple possibilities. I'm going to change this. I'm going to make this sodium, actually, because it's a little bit easier to find, so I can find you a picture of this. I'm going to go back to Google Images and show sodium chloride solvation water, and we'll see what we can pull up. If I look around here, booyah, right there. Pulls up a nice big picture of sodium chloride being solvated by water molecules. Notice the orientation of the water. The positive hydrogens point towards the negative chlorine. The negative oxygens point towards the positive sodium ion. If I was to look at a picture of the crystal when it was all together, it would look sort of like this. Again, this is it when it's all together. This is it in water. Isn't this amazing? And look, this is the University of Arizona's website. You can see this stuff comes up in college. We do this at a college level, even though you guys are in high school. You guys are doing great. You know what? And we're going to save ionic versus covalent compound properties for the next one. Actually, let's do one more question. When you sit, stand, or run, sit, or even stand, you are using your skeletal muscles. These skeletal muscles use multiple ions to function and contract. The ions that are used are a calcium influx and sodium-potassium channels that cause action potentials, or electrical signaling, to occur along the muscle. These ions are examples of. There's the key question. Now notice it says electrical signaling. The question's asking, what type of substances help electrical signals conduct through water? The answer? Electrolytes. Straight up vocabulary. That's all this test is about. Alright, if you want to see part 3, click on the next video.